Okay, so database questions, the big things to remember is that it's usually not that interested in your application of theory, like projectile motion. It's normally looking at your ability to connect with the data presented. So you have to read the case study, you have to understand what's actually going on. And in this case, it's pretty simple. You've got swimmers that have been measured over loads of trials with the dominant leg forward and the non-dominant leg forward. And then we've got measurement of force, contact time, which has allowed them to generate a mean net impulse applied for different starting positions. So you can see here, we've got dominant leg is higher than non-dominant leg, and loads of you pointed that out and you were able to get a mark for that. However, this question does ask you to think about influencing performance. So number one, it has improved the net impulse, but what does that mean? Well, if we've got a bigger net impulse, we know that impulse is equal, so FT is equal to mv. So we've got a net impulse. If it's bigger, we're going to get a greater change in momentum, and vice versa. So if we've got more momentum, then we should have a better dive, and usually that's going to mean faster. And if it's faster, and if the angle of release and all that is also considered, it might potentially be further, but it's definitely going to be faster if we've got a bigger net impulse. However, it does say using the data. So when you look at the data a bit more closely, some of you did talk about contact time and force, which is absolutely fine. But if you look at the difference between these values, it's only 8 newtons per second difference. You're only gaining a tiny little bit of force by changing your leg position, and that seems odd. So that's something that you could have pointed out. And I actually think this is a good moment to point out as well that 8 newtons per second might not mean a lot to you, but if you look at this as percentage change, we can look at the new value minus the old value, divide it by the old value and times by 100 to get the percent, and it's a 1.2% difference in performance. That's tiny. For an elite swimmer, every percent counts, but it's quite a negligible influence on performance. And remember that the question is asking you that influence on performance. There we go.